Welcome to a new lesson. In this lesson, we would understand how reduced site join is designed in MapReduce framework. To understand the joins between the two datasets, we would again take the same input datasets as we had discussed in the last lesson and try to achieve the same result. Here we will try to understand the main ideas and design concepts to see how to break the problem in map and reduce phases. First, we would look at the designing aspect, and at the end we would understand how to implement these. While designing a solution in reduced site join, in map phase we just tag the dataset records with its source, and that is all what we do in the map phase. Here both the input datasets would be treated to different map classes, which would just output composite key, which is a combination of project number and a number, and the complete record would be treated as value. In this case, the key on which the join operation is to be performed acts as a natural key, and the tagging number acts as a natural value portion of the composite key. The whole idea of tagging is that at the reduce phase, we would like the input to the reducer in the form as shown. You can observe that all the records with the same project ID from both the datasets go to the same reducer, as we would design the partitioner to act on the natural key portion of the composite key only, and here the natural key is the project ID. Another thing to observe is that tags would act as a natural value portion of the composite key, which would decide the sorting of the records, and because of these tags, the order of the records would be so that the data records which have the details of the project would come before all the records which have billing details. Here we want to expand the project details in the billing dataset. So here the relationship is one-to-many. And so the idea is that one record which needs to be expanded over the rest of the records should come on the top, and all the other records should be following it. Once we manage this, at the reduce phase, we just need to store first occurrence of the record and expand the same over the rest of the iterations of the values of that key to produce the final result. Now coming to the technical aspect of the solution. First we need to treat different input datasets to different map logics. This can be done by using multiple inputs object in the driver class. This is possible through the method multiple inputs.add input path. Here you can specify the job, path of the argument, and the input format, and the mapper class through which you want the datasets to be treated to. So here you can take input as multiple files to the job and treat each of the input file to a different map logic. This tool or idea is useful in all the scenarios where we have multiple inputs to the job. Each dataset has a different format and there cannot be a single logic to process all the different datasets. So in all such cases, this idea of using multiple input format is used. Rest all design ideas are the same as we had discussed in the case of secondary sort. There has to be a custom data type that extends writable comparable, which needs to be designed to handle composite key. All the necessary functions needs to be overridden for that custom writable. Then custom partitioner should be designed which considers only natural key portion of the composite key, and then there needs to be a custom comparator class declared so as to tell Hadoop how to compare the two records and sort on the basis of natural value portion of the composite key. Then the reduced logic would be simply to store the first record of the group and expand it in subsequent occurrences of value to reach to the ultimate output. This is the main idea when you are applying reduced site join in MapReduce framework.